noise, room noise. Okay, here we go. Welcome to Walkabout the Galaxy, the currently being listened to astronomy podcast, where the science is universal, the opinions are personal, and the sponsor is relativistical.
No.
We are Strange Truth and Beauty, the Astroquarks, also known as Josh Caldwell, Jim Cooney, and Zoe Landsman, coming to you from the Walkabout Studios at the University of Central Florida. Today we will not be charming, however, because Addie Dove is on assignment, and I couldn't bring myself to say top and bottom. I just said it. Jim.
Yes, sir.
Emperor Palpatine or Borg Queen?
Emperor Palpatine, because the Borg Queen ruined the Borg.
Oh?
Ruined it.
Oh, because she's singular?
I cannot tell you how upsetting that was when I saw that. I mean, generally that was a good movie. Which one was that? That was the
First Contact. Is that the first time we see the Borg Queen?
I think it was the first time we see the Borg Queen.
We don't see her in the show at all.
But the point of the Borg was they're terrifying. They were absolutely one of the best things that Star Trek ever did. They were terrifying because of their lack of individuality.
Yeah.
Because it didn't matter if you killed one of the things, right? That it was irrelevant to the collective.
Yeah.
To put all of this thing in the Queen, it ruined that for me, and it was very. I'm upset with that still. So, not that I'm some big giant Palpatine fan, but
okay. But you got a grudge.
Just on principle.
I got a grudge because Star Trek is close to my heart. I love it, and that wrecked a big thing for me. So.
Yeah, but the Borg Queen was a great character. I mean, I totally get what you're saying.
Agreed. Great character, well acted. It was a fun movie. It just the idea of it kills me.
Just like that's wrong.
Yeah.
There should not be a Borg Queen.
That's right.
Zoe, Galileo or DaVinci?
Ooh. Galileo?
Jim was biting his lip as though he was like,
no.
There's a right answer. You have, better say it.
I do not have a better
answer.
No, what do you got?
I don't have a strong feeling about that, but Galileo, just because, yeah.
Okay.
Astronomy. I think of him as being more associated with astronomy.
He was definitely more astronomy than DaVinci.
Yeah,
so.
that's all I got.
Yeah. I just finished.
Both cool.
I just finished Isaacson's biography of Da Vinci, and he did a lot of stuff that was pretty amazing that I wasn't aware of.
Right.
Including, in some sense, writing Newton's laws of motion out.
Really?
But he, like all of the things he wrote, it was just scribbled in his notebooks that were never published and that everybody had to rediscover over the course of the next couple hundred years.
Typical academic behavior.
Yeah.
So what years were that? I mean, when was
100 years before Galileo, roughly.
Mm.
Yeah. So well before Newton.
Right.
And he didn't, and it was not quantitatively justified or rigorously laid out. It was a statement. It was sort of a proclamation.
Right.
About forces or but he used words like Newton's laws, or like a force is an object will keep moving the way it's moving until a force does something to make it change that, or something like that. It was remarkably close
to DaVinci.
to Newton's laws. Yeah.
Yeah. If only he'd just written that down more carefully, he could have been even more famous.
If he had published some books. It's kind of amazing, actually, how famous and renowned he was in his own life, considering how stubborn he was and how little he published. And also, like, painting, he only painted like 15 paintings. And he was renowned as like this brilliant painter. And then he was just like, no, I don't want to paint that. And I can carry this painting around with me. It's not finished yet. And
oh, man.
Yeah. Today we've got a new study about so-called ocean worlds and how likely or not they are to be habitable underneath all the ice, which is where the ocean is, and then we'll talk about what's underneath the ocean. Some prognostication about the distant future of our own solar system.
Ooh.
And the history of impacts on Earth, some new results, or a new conclusion anyway, or study about the history of impacts onto the Earth. But first, this episode of Walkabout the Galaxy is brought to you by time dilation.
Ooh.
Always scrambling to make it to your next appointment?
Yes.
Never enough time to finish your homework? Alarm clock always going off too early? Are you one of the millions, maybe billions, who simply doesn't have enough time? Try time dilation. Doctor recommended for those times when you need to get to the future before everyone else. While time dilation may not give you more time to sleep, from your standpoint, you can simply relativistically travel to a time when all those deadlines, not to mention your boss, family, and friends, are merely distant memories.
Oh.
Time dilation. Leave your troubles behind.
Oh. That was a dark one.
Well,
clarification, so that the check gets sent to the right place. Or actually, they're sending us a check. Is this a special relativistic time dilation or gravitational?
Great.
Time I mean, there are two different kinds of time dilation.
Well, tell us about
It's true.
that.
Well, there's there's time dilation because you're moving fast, right? The faster you're going, the slower your clock runs.
Oh, right. Okay.
Then there's also
the
gravitational one. So the closer you are to a massive object, the slower your time runs. Both of those have to be taken into account. Like, for example, for GPS satellites,
Okay.
they're higher than we are up, so they clocks run differently, and they're moving relative to Earth, so their clocks run differently.
Right.
And we program both of those things into GPS so that we know how their clocks are going to be different from ours, and things don't get off.
Right.
So I just want to know who to thank when I see them on the street.
Well, let me ask: are they truly different, or are they just sort of different?
They are truly different.
Truly different.
I guess.
The effect is still the same, right?
Space and time and all that stuff.
Yeah.
So one is moving through space very quickly, but the other one is because you're in a region of space where space and time are kind of messed up, that you're still sort of, maybe.
I don't know.
Well, in any event, it is a single sponsor, and that would argue that they are actually the same thing.
Oh,
that's deep.
Mind blown.
Because you can basically park yourself near a black hole, or head off somewhere at 99.9% the speed of light. Either way, your time dilation will work to help you put your troubles behind.
True fact.
Okay? I would rather go very fast.
Yeah, sounds more fun.
Looking ahead a few episodes, we're going to have a science fiction author, Hugo and Nebula Award-winning author Joe Haldeman, who's one of whose books, The Forever War, time dilation plays a very important role. It's a forever war because of time dilation.
Right. Excellent, because one of the, I mean, I guess it's not a small number, but one of the sci-fi books that does it right.
Yes.
Time dilation.
Right.
They don't all, because it's easier to cheat.
Right.
And
those poor guys keep trying to leave their troubles behind.
They keep catching you. It turns out
just keeps going on. Space news. So there's an eclipse, a lunar eclipse this weekend. Maybe in the past for you listeners, but guess what? It's a supermoon.
Ooh.
It's a super blood wolf moon or something. There are many, many qualifiers in front of this moon.
Tell us about them.
Oh, I don't really know.
You
it's
said
just
wolf.
a lunar.
Is that really a thing?
Yeah, I'm not sure what the relevance of that is. It's a cultural thing. Maybe
it's a wolf moon?
It's a wolf moon. I don't know what. Maybe that's just the full moon in January or something.
Okay.
I don't know. But
there's always something special about the moon.
I've seen that list of qualifiers for this particular event.
Say
Super wolf blood moon.
So that's kind of terrifying.
I had seen the blood in the super.
Not leaving the house.
So super is an act. We can define that because the supermoon is because the moon is not on a perfectly circular orbit around the Earth. There are times when it is a full moon when the moon is at its closer to the Earth than other times, so it looks a little bit bigger.
Larger, yeah.
Not to be confused with the psychological perception of a larger moon when it's on the horizon.
Right.
Which is a purely mental construct thing and doesn't have anything to do with optics or refraction or geometry or orbits or anything.
Right. This is a genuinely slightly bigger moon.
It's genuinely slightly bigger.
Which is actually not such a great thing for an eclipse because it makes having a total eclipse
a little bit harder.
Because you have to cover the entire. But we will be having a total eclipse on this coming Sunday for us. Maybe this
North
past
America.
Sunday or some other time for you. Maybe
all of the Americas will see
a
total solar eclipse, and that's January 20th into 21st. Yeah, the night of the 20th into the 21st. Go ahead.
So
January
apparently,
2019.
Correct.
Who knows when people are listening to this?
That's true.
This episode, I have a feeling this episode is timeless.
Yeah, it's going to be iconic. People in 30 years from now are still going to be listening to this episode. Let's be clear.
Some people may have heard the sponsor message, gotten on a spaceship.
That's true.
And
Very true.
Had lunch while traveling at a relativistic speed, and then listened to it, and it's 2050 or something like that.
So the wolf moon is apparently the January full moon, and that is because Native Americans and colonial Europeans gave it that name, as January is when the wolves would start howling out of hunger because it's midwinter and there aren't tasty things to eat.
That's sad.
So it's a sad wolf moon.
It's a very hungry wolf moon.
It's hungry
like a wolf. Dated
Jinx.
ourselves. Yeah. And it's blood red, but isn't every frickin' lunar eclipse a blood red moon thing? So
I don't like this trend of putting this list of qualifiers in front of every interesting
these
celestial event.
Things.
Yeah,
right.
because I think it just makes it less special over time.
I agree. I think it makes us look like dummies.
Yeah.
Because people go, it's like, that looks just, what's the difference between this one and the last one I
this
saw?
is the only one to happen in the next 80 million years. It's except for the next lunar eclipse that will be maybe not a super or a wolf moon, but
it'll
similar thing.
It'll be a coyote moon.
Yeah.
And, and whatever. So it's red just because of the Earth's atmosphere, right? So the Earth's shadow is on the moon, but because the Earth has an atmosphere, sunlight shines through it, and the red light is more refracted by the Earth's atmosphere, and so you get more red light from the sun on the moon.
I don't think you said that exactly right.
Oh, well, correct me.
Well, the red light is the light that gets through. It's less scattered, and so it's the light that gets through the atmosphere.
Oh, the blue light is scattered.
Blue light is scattered out.
Away.
Because it's weird, right? At first you'd think you see a fully eclipsed moon, you shouldn't see anything, right? Because it's like all of the light from the sun is being blocked by the Earth, so there should be no moon at all that you see, but you still see a moon, and it's very red. And that's because of the light that is gently bent through the Earth's atmosphere around the Earth. But most of that is scattered so significantly that it's gone entirely, and that's the blue, and what's left is the red.
Right. So that's what we call Rayleigh scattering, same thing that makes the sky blue to us, because we look at a direction very far away from the sun.
Right.
The blue light is scattered
light
towards us. Yeah. Physically, what I said about refraction is true, but it's not the explanation for why only the red light is getting through, is what you're saying.
Right.
Yeah.
Right.
Thanks.
So it's kind of poetic, by the way. I'll let you go on. It's like when you're seeing that red moon that's fully eclipsed, it's like you're seeing, reflected off of the moon, the light from all of the world's sunrises and sunsets at that time. Isn't that nice?
That's so pretty.
Isn't that nice?
So, and if you were on the moon during this time looking, you would be seeing what we would call a solar eclipse, basically. In other words, the sun would have the Earth passing in front of it. You would see a kind of a ring of fire around the Earth, right? It would probably be, or what would you see? Because
I don't know what is the angular size of the Earth and the sun?
It's much bigger than the sun.
From the moon.
So when from our standpoint on the Earth, when the moon passes in front of the sun during a solar eclipse, the disk of the moon is just slightly larger than the disk of the sun, and so we see the sun's atmosphere. But the Earth is 4 times bigger than the moon.
Right.
Mm-hmm.
So the sun is going to be totally gone, and you're just going to see this.
So
it will be like
really won't
an
see
illuminated ring right around the edge of the Earth that is the Earth's atmosphere, glowing red.
So here we see the sun's atmosphere in a sense when we look at a solar eclipse we see what we call the solar corona, the sun's atmosphere. If you're on the moon during this event, you would see this red ring that would all be truly due to the Earth's atmosphere or something like that. Cool.
Yeah.
We should do that sometime.
Let's go to the moon.
We should totally go there.
I want to be
check
next
that out.
next
Get
podcast
that picture.
from the moon.
Yeah. There may still be time, dear listeners, unless you took a relativistic journey, to enter our first listener contest. How many launches to space will occur in the year 2019? Space for this purposes of this contest is 80 kilometers or higher. Send one response per your email address to josh@ucf.edu with WTG contest in the subject line by January 31st, 2019, with your chance to win a free WTG t-shirt. Closest guess wins, not Price is Right rules. And if you can't wait till the end of 2019, we'll have information at the end of the podcast about purchasing shirts. So, I heard something really stupid about climate change on the radio, but I'll come back to that later.
Okay.
So let's talk about the Ocean World study. Ocean Worlds is NASA's sort of PR catchphrasey name for places like
Europa, Enceladus.
So places that Earth is really the ocean world.
Right.
But so these are worlds where there's liquid water somewhere.
Well, presumably under the surface that is icy.
Yeah. So deep down, depending on which one we're talking about, a different distance in. And so for Enceladus, we see these geysers coming out of the south polar cracks, and it seems pretty clear that there's liquid water under the surface, and it may not be too far from the surface, where not too far includes up to maybe 10 or 20 or 30 kilometers deep. So it's still very deep
down
underneath the surface from our sort of usual standpoint. But Europa's deeper.
Europa's likely deeper, but almost certainly there. The other moon, Europa is, of course, the moon of Jupiter. Jupiter's other big moons may also have them, especially, what's the next one out from Europa?
Ganymede.
Ganymede.
I was trying to get through it in my head.
I wasn't trying to put you on the spot there. I apologize. Yeah, so Ganymede seems to have indications that it also has a liquid water ocean.
Based on its magnetic field.
And it has some weird surface features as well. Some of the surfaces is young looking, as if there's stuff happening underneath, and some of it is older looking, so it probably does. Callisto, which is the most distant of the moon from Jupiter, the most distant big moon from Jupiter's. The evidence is less strong, but there's still, I think, an anomalous magnetic field that is difficult to explain without something. So maybe, and Titan also, likely, possibly, ocean under there. So there's a bunch of places in our solar system, just in our solar system, where there's liquid water. And of course, as we've said many times, liquid water means
life.
There definite life.
Klingons.
Aliens.
And
fish.
And so, as you mentioned, there's all these moons in our solar system that seem to have liquid water oceans on them. And now we're discovering all these planets around other stars, and a lot of them look like planets like Jupiter or Saturn, big planets that probably also have moons.
Yeah.
And because those planets are much closer to their stars, in a lot of the ones that we've discovered, those exomoons are also talked about as possible homes for Borgs and Klingons and things.
Right, super exciting. Really considerably multiplies the number of places in the galaxy that you could think that life would have a reasonable chance of evolving.
Now some scientists come along and ruined it, though.
Partially. They threw a little bit of a dart at this. The idea is, so you have a liquid water ocean. That there's a little bit more than just that you need for life, right? So you need also the elements, carbon and nitrogen and various things that you can make together to make these complicated organic molecules. And you need kind of some energy, right? You need a source of energy. So, for example, in recent years, I think we talked about this in a recent podcast, that people have been thinking that maybe life on Earth didn't evolve in tidal pools and things like that, like we used to think, but maybe these things like these black smokers, right? These places where there's vents in the bottom of the oceans, and there's superheated water coming up that also is, nutrient rich. And anyway, we find these cool environments down there. Maybe life evolved there. Well, it seems that might be difficult on some of these icy worlds.
So that was exciting for the astrobiology standpoint. It's like, oh, cool. Yeah. We don't need tidal pools if we've got energy underneath, and these things may have that.
Right.
So what's this new research say?
I guess the new research says...
That's actually the title of the paper.
Yeah.
That
it's just that sound.
If you go down to the rock, so on these worlds, it's like the surface is ice, because it's really cold out there. Underneath that, there's some layer of ocean. And then underneath that, there's kind of rock and metal, the kinds of things that you see on Earth. But you can do some calculations, and the people in the mining industries and stuff like that do these calculations. But you do these calculations to figure out how kind of rigid the rock is underneath these oceans,
right?
Based on how much weight is above them.
So compressing the rock.
And what you need to have these, you need to have these vents is cracks in the rock. So the rock has to be able to be cracked. And it seems like, from these calculations, that the rock underneath these icy worlds is likely to be too, I don't know if rigid is the word, but too tough.
Stiff.
Something like that to sustain, to have cracks. And so you're gonna take your submarine along the bottom of these oceans, and the ocean floor is going to be extremely boring. You're not going to see mountains and volcanoes and things like that like you see on Earth's ocean floors. It's just going to be
like a billiard ball.
Dead flat. Billiard ball, flat, with nothing interesting happening. And that...
Like my head.
Could at least... You said it.
Billiard ball, dead, flat, nothing happening. Yeah. All of the above apply.
Yeah.
So, yeah. So, yes, this was research by Paul Byrne, a planetary geologist at North Carolina State, and he presented this at the AGU meeting last month. So, as you were saying, Zoe, it's a little bit womp-womp.
Yeah. Right. Well, and even the author of the paper said that he's kind of disappointed in his own
results.
His own findings.
I think that they were hoping when they started those calculations that they'd show there are cracks, and that'd be great.
Yeah.
Of course, this is just a very preliminary thing. It's based on theory and not on any observations that we've made or anything like that. So it certainly doesn't automatically rule out all life on these ocean ocean worlds.
Right.
But I think that it illustrates a nice thing about science, that science, if you're doing it right, the results you find aren't necessarily the thing you kind of emotionally hope to find.
Yeah.
Right.
Yep.
If you're going to be a good scientist.
The process.
You got to have the courage to accept the results, even if they're not what you want.
Is set up to make that happen. And part of that is going and sharing stuff at meetings where other people can say, is that really the answer? Is that the answer you wanted to see?
Mm-hmm.
And so there's a lot still of activity towards exploring these ocean worlds. So the Europa Clipper mission, which we've talked about before, is going to be a Jupiter orbiter launched in a few years that will be flying by the moon Europa many times. And one of the things they're looking for are sort of the upper part of that ocean, so the cracks in the ice and the communication between the water below and the surface. Since we can't, those oceans are so deep, forget about it. We're not getting down to those oceans anytime soon.
Yeah.
But sometimes nature helps out, and it puts some of that material out on the surface, and then we can see something about it. So they'll be looking for organics, complex molecules, and we'll see. But those, even though Europa and Enceladus, all those moons are much smaller than the Earth, these ocean and ice layers that we're talking about on them are much thicker than the ocean layer on the Earth. On the other hand, their gravity is less. And Enceladus, I think it was not as clear.
Right, that's what I thought, when we read the paper. Enceladus, the rock might be brittle enough to break up.
So this is this moon of Saturn that has geysers, and it's significantly smaller than Europa. And so it has a weaker gravity, and so even if it's got a 30 kilometers or 100 kilometers layer deep of water and ice on top, it's not pushing down on the rock underneath as much.
Right.
The flip side is, though, because it's smaller, it has less internal energy to do stuff with in the first place.
Sure.
Right. So I always use, maybe you've got a better one, you guys, since you teach intro astronomy, the analogy of baked potatoes and peas. In terms
say again?
What now?
Explain.
What? You mean you don't use baked potatoes and peas analogy in your intro astronomy class?
I would never use
the well-known.
peas.
Well.
Gross. Anyway, go ahead.
One of the problems with peas is they cool off really quickly. But your baked potato stays toasty warm for a really long time.
It's true.
And so the larger moons stay toasty warm. They have a lot more energy and hold on to it longer than the smaller moons. So Enceladus is a pea.
That analogy.
There you go.
Mm-hmm.
Seems like grown-ups and babies, right? Got to keep the baby warm. The baby's going to get cold, right? So, okay. Jim, I understand that you have brought a trivia for us today.
Yes. So this will relate to I think, the next topic that we're going to talk about.
You're going to segue us?
Yeah, I'll segue you. The next topic we're going to talk about is
trivia segue us.
Nice.
The potential for a galactic collision. So the Milky Way, For years and years, I won't spoil the whole thing, so I'll get to but for years and years...
Just spoil it a little bit.
To spoil it a little bit, we've always thought that we might collide with the great galaxy in Andromeda, because it's our biggest, closest neighbor. It's got a lot of mass. We got a lot of mass.
And it's kind of heading towards us.
It's heading towards us, right. So when we look at the light from it, it's blue-shifted. It's heading our way. So maybe in 5, 6, 8 billion years, we're going to collide with it. Well, it turns out we're in danger before then.
Oh, no.
Sound the alarm.
Sound the alarm. More like 2.5 billion years, we got a problem with something other than Andromeda, and we'll talk about what that is after the trivia question. So since we're talking about galaxies colliding, but just galaxies in general, here's a quick galaxy...
collision trivia?
Collision trivia. Not collision trivia, just galaxy trivia.
Galaxy trivia.
So most... and this one I think, I'm not sure, but I think will be... easy for you guys, and not necessarily for all the listeners, but for some of them it will be easy, some not. Here it is. Most galaxies have, like, silly catalog names.
True.
Excellent job.
That's
not the question. Silly
Darn.
catalog names. They, with some letters and some numbers, because there are literally trillions of galaxies out there in the universe. It'd be silly to name them all proper names, but...
That's just your opinion.
That is my opinion. But some of the more well-known... brighter, bigger galaxies have actual names associated with them. So which of the following is not an actual galaxy?
Oh.
Ooh.
Okay. We've had a series of which of these is not,
I
real
don't know why. That's like my go-to thing when I write it. I don't know why. It's stupid. Mostly because I just like to make up stupid names for things. But
but the challenge, though, and my hat's off, is then you have to find a list of things that actually do have stupid names that your thing could plausibly be a member of.
Right.
So you did it.
And I might not have done a good job on this one.
Okay.
I think I've done a good job
We'll
in trivia questions past. But anyway, here are your options for galaxies. One of these is not an actual galaxy.
Do not blurt out your answer. So.
Do not blurt out your just hang on to it, and we'll come back to that later. Your choices are A, Zwicky's Vorwerp.
Vorwerp?
Vorwerp.
Zwicky's has got an apostrophe.
Yes.
Like as in Franz Zwicky's. And it's V-O-E-R-W.
V-O-O-R-W-E-R-P.
Vorwerp.
The black eye. Okay.
Whatever.
Zwicky's Vorwerp.
I don't know what I'm talking
about. The black eye galaxy.
The
black eye galaxy. Yeah.
And
Hoag's object.
How's Hoag spelled?
H-O-A-G.
Okay.
Hoag's object. The tadpole galaxy.
Oh, there's so many.
There's just one more. And the cigar galaxy.
Okay.
All but one of those are actual galaxies. I'm sure you've heard of at least a few of those. But let's see if you can narrow it down to the proper answer. Mull that over, listeners. And
All right.
We'll come back and see which one of those.
Josh.
All right. Cool. Okay. Well, since you segued us, hey, Jim, talking about galaxies.
Galaxies.
What are the chances that a galaxy might run into the Milky Way in 2 or 3 billion years?
Pretty high. According to a new study by some folks.
This just in.
Scientists warn.
Batten down the hatches, folks.
What was the warning one we had recently? Oh, Saturn's rings are young.
Yeah. We're losing Saturn's rings. The scientists warn.
Scientists warn Saturn's rings may not be around forever.
Yeah.
Now it's scientists warn we may have a collision in 3 billion years.
Yeah.
Be warned.
So, get your affairs in order, because we're going to get hit. This one is by, our closest big neighbor galaxy is, like we said, Andromeda. But we have some closer galaxies, and there are these small dwarf galaxies. The largest of those, the small dwarf galaxies, is...
the Larger Magellanic Cloud.
Right, the Large Magellanic Cloud. And that sucker seems to also be heading toward us. So it's a little bit hard to figure out what the orbits of these dwarf galaxies are like. Because it's not like a planet. Like when you discover a new asteroid or comet or something like that, you can figure out its orbit by just watching it over the course of a few weeks, months, year, see where it is, where it's going. With a galaxy, of course, they're very far away and they're moving very slowly, and so you can't map out their orbit by watching them over the course of years. You have to figure it out based on, the red shifts and blue shifts and random things like this.
You get something about some kind of direction it's moving from that spectral redshift.
Kind of, but you only get some of that. You only get how far, if it's moving toward or away, but you don't get whether it's moving to the side, and you don't. Anyway, but the most recent work suggests that we will be colliding with that thing, and that actually It's not such a terrible thing.
Is it backing into us?
It sounds very bad.
No, I say that the Milky Way galaxy we like to think of as some like prototypical galaxy. It's a nice spiral galaxy of kind of average galaxy size, but the Milky Way actually has some aspects of it that are quite unusual compared to typical galaxies. One of those is our central giant black hole at the center of our galaxy is considerably smaller than it should be.
Not that that's important.
Should be, right.
Yeah, doesn't matter. It's okay.
That's okay.
No judgment. No value judgment attached to that. It's about 1 million times the mass of the sun.
I want to say something like that, but that's smaller than the typical supermassive black hole at the center of a galaxy of our size.
Well, so do we know, for example, how massive the black hole is at the center of the Andromeda galaxy?
Yeah, it's larger.
So like at least a factor of 10
like
larger?
A factor of 10-ish larger.
Okay.
So, and this is that's more typical for spiral galaxies of our size. Some other things as well, like a fancy word that we like to use in astronomy is metallicity.
Yeah.
The amount of heavier elements in the halo of our galaxy is not typical. These are all, like little-ish things that you wouldn't worry too much about.
I wouldn't worry about them at all, frankly.
And we think the reason for that is that our galaxy actually has not undergone very many collisions. We think most galaxies, our galaxy's been around for about 10 billion years or so, and we think the last big collision between us and something like the Magellanic Clouds happened maybe 9 billion years or something ago. So it's been a very long time.
Since we've had a major thing come through.
We've
had some stuff. I mean, we recently were talking about a stream of intergalactic stars passing through the neighborhood.
Right. So small, little tiny dwarf galaxies and things like that we may have enveloped, but
those are just like streakers or something.
So will this event make our galaxy maybe more like the other galaxies?
So that's the thought, is that we'll collide with this galaxy, and what are the consequences of colliding with the large So mostly we will cannibalize it because it's much smaller than us. Not death and destruction, but it will actually be kind of cool and spectacular because it will likely spark a bunch of activity in our supermassive black hole at the center of the galaxy. It will start eating a bunch of gas and dust that comes from the Magellanic Cloud, and that will cause activity in it. It'll start streaming away a lot of radiation as it eats material. It's going to be awesome.
So we were talking about the search for life with these ocean worlds, so that's become a kind of focus for NASA, is like looking for life there. And one of the big things we talk about in searching for habitable areas is the so-called habitable zone. So the habitable zone around a star is based on not too close where it's too hot, not too far where it's too cold.
The Goldilocks zone.
Where you can have liquid water typically, and so these ocean worlds sort of skirt around that by burying the water underneath. But there's also this notion of a habitable zone in a galaxy, the galactic habitable zone, where you're not too close to all the crap you were just talking about from the supermassive black hole. Is it possible? Does this tie into the Milky Way being sort of a more habitable, more life-friendly galaxy as a whole because it hasn't had these galactic mergers?
Conceivably, yeah. I mean, our supermassive black hole has not been very active for a very, very long time.
That's too much information, really. But after this collision, then
could be an issue.
All that stuff that you're talking about would make stellar systems in that region maybe not so habitable anymore.
So if you're a star living fairly close to the center of the Milky Way, you might find your environment is pretty nasty after this event.
Yeah.
For us, we'll be fine. Right,
well,
we live far enough away. Speak for yourself, sir.
Unless you sign up for time dilation.
There you go.
That's right. You
can
just
get in a spaceship.
Skip to this part.
Skip to that part.
Yeah.
See what happens.
You could actually do that. That's a real thing. If you went fast enough.
With the right technology.
But you'd have to go really fast.
You would need a lot of energy. You'd need a lot of energy.
You need a lot of energy.
Right.
But it's out there.
And a lot of...
Universe is filled with energy.
You need a lot of cereal and Coke, and all those things to keep you going.
Sure.
But yeah, so anyway, for as far as our solar system, not much to worry. Although, the authors of this study note that in any kind of collision between two reasonably sized galaxies, there's always some fraction of stars in that galaxy which are going to get kind of flung out. It's very unlikely that we would collide with another star from another galaxy, but gravitational interactions might fling us out of the galaxy, which, again, who cares, doesn't really matter for us in our solar system, but does make for a really different night sky, for example.
Right. And actually that's an interesting thought. So suppose that had happened billions of years ago, and our solar system had been flung out of the Milky Way, but we're still, galactically speaking, in a habitable zone. The Earth is still nicely in the Sun's habitable zone, so the Earth's still a lovely place. But the night sky does not have the stars in it.
Right.
It really doesn't have stars at all. It would have these distant nebula that you would only see really with a telescope, or maybe you could maybe see the Andromeda or Milky Way as a little smudge. I mean, it's interesting.
You wonder how history would have been different, right?
Yeah, without stars
science,
at all.
Right, because a lot of modern science was like people looking for trying to understand how planets were different from stars and things like that, and did modern physics and all these. I mean, like
we're partly inspired by these observations.
Yeah.
And so there may be civilizations out there, or wannabe civilizations, or frustrated civilizations that their stars got kicked out of the galaxy and they're just wandering around in intergalactic space.
Yeah, very dark and lonely.
Yeah.
Aww.
But they don't.
It's just a sad episode.
But they're not.
sorry, listeners.
Run away from your problems with time dilation. No life in the ocean worlds.
Right.
Dark, lonely space.
And if the galactic collision wasn't bad enough, it now turns out, perhaps, that regular old collisions, asteroid-type collisions, are happening now at a greater rate than they were a few 100 million years ago.
I don't know. Yeah, you tell me this is
I'm on deck here for this? Sure.
Topic of the day.
For the third half of the show?
So my understanding of these new results is that the problem with figuring out how many impacts there have been on Earth is that Earth has very active geology and wind and rain and oceans and things that erode the surface. But you can use the moon, which is roughly the same age as the Earth, as kind of a proxy, since the moon doesn't have its craters being washed away. So you can count craters on the moon as a proxy for what happened on Earth. So I guess what they did with this recent paper, sorry, I'm looking at my notes here, is they have a new way.
You're not allowed to have notes.
This is
just
a closed
kidding,
book.
I don't have
this
notes.
Is a closed book
exam,
podcast.
crap. So they're using a new, more accurate way to age the craters on the moon, that is to figure out which ones are young and which ones are old. And so doing that, they found this increase in young ones.
In other words,
more young ones than old ones.
Right, yeah.
An uptick starting like 300 million years ago, 290 million years ago.
Right. And it's as you said or alluded to, it's a complicated problem because there is all that erosion on the Earth.
Right.
And all that stuff. So there's this lunar uptick, and then also I think they were mentioning, we don't see as many super old craters on the Earth as we kind of thought we should.
Right. I mean, it's statistics of small numbers a little bit, just because there are so few known craters on the Earth because of the erosion issue. But this idea, maybe we don't see so many old craters on the Earth, seems to be also the case on the moon, where you have more robust statistics.
Right. So they're and how big an uptick are they talking about here?
I think it was about it was 2 to 3, a factor of 2 to 3
times more. Yeah.
But this this all relies on this new way of aging the craters.
Why do you guys say aging instead of dating?
Dating
craters is so much more fun than aging craters.
Really? Craters?
Just trying to keep with the theme of today's podcast. Just
as depressing
and
sad. Dark and sad. Dating is too festive.
Yeah, that's right.
But yeah, this new method, and we don't need to go and describe it. I don't know, it's some complicated thing, but it seemed to me like it was
it had to do
a
with
little
carrots.
Bit sketchy.
It had to do with carrots.
Carrots?
There was something about, I did see that, but I don't remember what that had, what the gist of that was. There's something carrot-shaped that does something related to this, but I don't know what. Informative. The Informative Astronomy Podcast.
The Informative Astronomy
Carrots
Podcast.
And peas?
Yes. And potatoes.
Potatoes?
No, there's some geological structure of the shards that are created, so that's related to the age of the crater, and so they're carrot-shaped.
I mean, I think, I
guess that's the journalistic analogy for conical.
Right.
Yeah. Right.
And I didn't mean, by the way, to if the authors of this study are listening, to demean the paper or anything. It's probably right, but it's worth mentioning that these things, like, we like to gloss over that, like, oh, a new way of aging or dating. Craters.
Whatever.
As if all of a sudden we found a way to like actually definitively read the age of these things. It's just like, these procedures are complicated and rely on assumptions and this, that, and the other thing. So you have to take that with a little bit of a grain of salt. But it's an interesting result.
Let me clarify the carrot business.
All right, go ahead.
Since I brought it up, so I should clarify and correct the record.
The Correct Astronomy Podcast.
So the self-correcting. Kimberlite pipes.
That's what it was.
Are geological features that are carrot-shaped that form during explosive eruptions. And the authors of the study found not a lot of erosion in these features that were over 650 million years old. Therefore, they conclude craters that old would also be visible. So it's a little bit of just sort of part of their argument for erosion wouldn't wipe out all of the craters back to 650 million years or a billion years. There's this other issue, though, about snowball Earth, and it's like glaciers, and so at some time in the past, you go back far enough in the Earth, forget about it. You're not going to find any craters.
Right.
And that number's not a billion years.
Right.
So.
Right. Well, so my understanding of the way that they actually figured out the improved ages of the lunar craters in the simplest terms is they just looked at the temperature of them. And so you would expect, I think it's that the younger craters are warmer, and that has to do with how much, maybe I'm saying this wrong, but how much insulating stuff has built up on the craters. So that when they're fresh, they'll have kind of different properties as far as what the texture of the surface is like compared to when they're old.
It's not their temperature based on the crater forming event. It's how hot or cold they get now, based on how much weathering they've suffered.
That's right.
I like so Jay Malash he's a famous impact planetary scientist studying cratering who was not in the study, and he's quoted in the New York Times as saying, "All these problems would be solved if we could just get to the moon and date, not age."
He knows better than I.
And date 10,000 craters. So there you go. So we can just do that. Just go to the moon.
Easy.
Piece of cake.
We'll have Elon Musk's crew, get there and take care of that.
Sounds
All
good.
Right. Well, let's answer Jim's trivia.
All right. So I'll remind you once again, most galaxies have silly catalog names, but some have more traditional kind of names. Which of the following is not an actual galaxy? The choices were Zwicky's Vorwerp, the Black Eye Galaxy, Hoag's Object, the Tadpole Galaxy, and the Cigar Galaxy.
Guess.
I'm pretty sure it's the Black Eye Galaxy, but what do you have? Cigar
The
was
Cigar
one?
Galaxy, Tadpole Galaxy, Hoag's Object, Black Eye Galaxy, Zwicky's Vorwerp.
I don't know. Hoag's Object would be but I think it's the Black Eye Galaxy.
I think I know that the cigar one's a real one.
Okay, that part is right. Cigar Galaxy is a real galaxy.
That one I know, because wasn't there was some event there at some point? It was a supernova. It was in the news.
Tadpole Galaxy, also real.
Yeah,
sounds real.
That one I was pretty sure was real.
Hoag's Object, also real.
Okay.
So it's down to the last two. It turns out you guys are both wrong. It is, in fact, Zwicky's Vorwerp.
Really?
It is the made-up object found by an amateur astronomer in data.
Interesting.
That is really cool. But anyway, Zwicky's Vorwerp is a made-up thing.
Okay, cool. Well, since we've been talking a little bit about life and impacts, I just want to mention this, especially since I teased it at the front of the show about a stupid thing I heard on the radio.
Yeah.
So they were talking about the effects of climate change on things like mosquito populations and diseases, like Zika and West Nile and dengue. And a person that was being interviewed on the radio, a layperson, opined that climate change is not occurring on the Earth, but that if it were, that to suggest that people have anything to do with it is, quote, obscene.
Obscene?
Obscene because people only live on the land, and the land is only 29% of the surface area of the planet. To which I have many rejoinders, but in the context of today's show, I could say that an impact from an asteroid that was only made a crater 60 kilometers across wiped out 95% of all species on the planet 65 million years ago.
Oh, clearly that's wrong.
As one example,
That's true.
the Mount Pinatubo eruption only 20 or 30 years ago, 1991 or 92, actually lowered the global average temperature by 1 degree Fahrenheit
Impossible.
for a couple of years. So, womp womp. Yeah. Well,
then.
It may have felt like the time to wait for your friend to return from a relativistic journey. It's just been another episode of Walkabout the Galaxy. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com, where you can also see our new WTG t-shirts. While we're working on getting our automated ordering set up, if you're interested in t-shirts, send an email to me at josh@ucf.edu with the subject WTG and the size, style, and color you're interested in. We're also on YouTube at Walkabout the Galaxy, where you can see us roll our eyes at the other astroquarks. Follow us on Twitter.
At walk_the_galaxy.
Okay. Where you can ask us questions and suggest topics that you'd like to hear us discuss. Our theme music was composed by Richard Jerusik. Our production assistant is Diego Rodriguez. Catch up on old episodes wherever you get your podcasts and write us a review in binary. And literally change the universal value of the number pi 1,000,000 digits in by putting the review inside the number pi so that it's actually part of the number pi.
That's a challenge.
Whoa.
I'm Josh Caldwell.
I'm Jim Cooney.
I'm Zoe Landsman.
We're the Astroquarks, signing off until the next episode of Walkabout the Galaxy.
Astro quarks do. Sorry, everyone.